I want to demonstrate the amazing ability of this metallized mylar, which is only about a fraction of the millimeter thick. Its amazing ability to block radio waves. Now here I've got a little signal generator and an antenna, and that goes into a power meter. And I'll zero the power meter. Yeah, it's hard to do. That doesn't really matter any what it says on there, but I'll just show you. I'll turn on you saw where the signal generator was. I'll turn it on. The antennas are very close together. You can see that it goes up to 30 microwatts. Okay. Now, 30 microwatts is what this antenna is detecting and sending back to the meter from the signal generator with this setup here. One layer of the mylar Faraday shield or shielding material, and look at how much attenuation we have of the radio signal. So when the radio signal is not on, it's somewhere about 1.8 milliwatts. Microwatts, I should say. Now that's it turned on, and that is how little of the signal is being received. Now I'll remove the mylar and look how it increases. It goes up by a factor of almost 20 times. So now it's measuring almost 20 microwatts. Here I'm showing a tracking generator. Here is the transmitting antenna, and here is the receiving antenna. I have this attenuator sleeve of 3 layers of mylar, and it's got aluminum in it, so it works as an excellent attenuator for radio waves. So our display is down here, and I've got the tracking generator vertical because it just makes it more efficient. So let's just get a little closer to the display here. Okay, this here is the response of the signal. This is vertical, this is the signal strength, and this is frequency across here. So it's a graph. Here some frequencies are getting received much higher than others. That isn't important to us. What I'm showing is the frequency span here is 37.5 megahertz to 2000 megahertz. The vertical is, each division is 10 dB or 10 times. So here we've got, this dip here is the original cell phone band, which is about 900 megahertz. And since the original cell phones came out, they have now moved down into the 700 megahertz band, and they go all the way up to 2000 megahertz. Now what I'm going to do here is show how the response drops with this sleeve on. Okay, so take a look at this dip here, which is about 900 megahertz, and that's sitting at about a level of minus 70 decibels. Now I take the sleeve off, it goes up by 20, which is 100 times. So with the sleeve on at 900 megahertz, it attenuates or stops the signal by about 100 times. So the signal that is received with the sleeve on is 100 times less than the signal received without the sleeve on. Now let's look at other frequencies. Let's look at 1200 megahertz, 1250 megahertz, which is a bit higher. Okay, so you've got it sitting at approximately minus 40 dB. And it goes down to minus 62 dB. So that drops at that frequency by about 22 dB, which is a bit over 100 times. Now let's look at 1500 megahertz. With the sleeve on, it sits at about minus 48 dB, and with the sleeve on, it sits at minus 38. So it drops by about a factor of 10 at that frequency. Let's just go up to between 1750 megahertz. Without the sleeve on, it's sitting at minus 30, and with the sleeve on, it drops down to about minus 42. So at the lower end, there seems to be a bit more attenuation. It varies between 10 and 22 decibels of attenuation, and that's with 3 layers of mylar. So it's around, varies between 10 and 100 times attenuation, depending on what frequency of cell phone band you're using. So I thought maybe 5 layers I would use when I make the cell phone pouch, and that should give me a very high degree of attenuation. Once I've made the pouch, I will do this test again. So here is the cell phone, here's the mylar, and I'm going to bend this over and put a strip of tape down here, and the mylar is fitting loosely around the cell phone. So here I've put tape over the plastic. I folded the plastic mylar over itself with the cell phone inside, and I've just taken this dollar store gray packing tape. I'm using it to coat the entire bag here, so it'll all hold together well. So here I've got the bag in the same position that I had it when I was using just the mylar sheath. And only this, what I've done here is I've taken the transmitting antenna and extended it the whole way. And we've got the receiving antenna just as it was. Now, down here, we've got let's say 900 megahertz is about minus 45, and I take the bag off, and one portion of it goes down to minus 75. So that is a 30 dB change. So 30 dB attenuation. Some frequencies don't change a whole lot, but that's because it's leaking through the bag itself, through the openings in the bag. If that bag was sealed tight, you would have much better attenuation. Now I've got the bag sealed much better, and I'll show you how the response changes when I remove it. I'm going to do one more thing. I'm going to extend the upper range. I'm going to see what the sweep looks like from about 850 to 2600. 2500 is where the Wi-Fi is. So now we're looking at 850 megahertz to 2600. At the higher frequencies, we don't have a lot of change. Almost all the change is down in the old cell phone band. Got enormous change there. Why is this? It could be because a lot of the signal is leaking out the bottom. But of course, and the orientation of the bag, the very short wave getting up into the microwave region, the wavelength is very low, very small. So the radio waves are bouncing in and out and are leaking out of the smaller openings. So what I'll do is I'll tighten that with a couple of close pegs, and we'll see what the response is. So now you can see a much more even response. It doesn't even dip down here. Now I'll take it off. Now we've even developed a pronounced dip up around 2250 megahertz. Interesting. So here we are, we've got a response there. I've got the bag over it. Now I'm going to squeeze all the locations where it is coming out of the bottom. I'm squeezing it right around the antenna, and there it is. It's up around, if you look at the upper end, 2500, it's about minus 30 to minus 32 dBm. And when I put the squeeze on it, 2600 is way down to minus 70. So the upper end is being attenuated when I squeeze it by 30 dB. Here we are at there's minus 40. Takes a while to settle down. That's without the bag on. Put the bag on and squeeze it. $30 dB. It's 1,000 times the signal is being received. They're right next to each other. There's two antennas. I put the bag over and it blocks it 1,000 times, so that the antenna, the receiving antenna, is receiving 1,000 times less signal. So this bag is very effective with its 5 layers of mylar. So it's a pretty good bag. I'm just going to have to take the top here now and seal it so the cell phone can not send any signals. It will block the cell phone signal much more because the cell phone will sit here and there's just a small area patch antenna that the cell phone has inside it. So it'll block it here right in the middle. This one here is sending out in all directions. It's an omnidirectional antenna. So it's all sending out here, and then some is coming down. That's what's leaking out. And the shorter the wavelength, the more leaking you have. So anyway, I think that aptly demonstrates that this bag is very effective at blocking most cell phone frequencies at up to 1,000 times. At the very least, it's blocking it at 10 times. As I said at the beginning of this video, the main reason that I'm wanting to have a cell phone in a bag is so I can carry the cell phone in my hip pocket, and it'll cut down to almost nothing the radio signals that are going into my kidney or into higher up. If I put it in my jacket pocket, it will attenuate the signals going into my vital organs higher up, like the heart and such and such. So here I kept on wrapping tape in, and right up at the top here I made the entrance quite even, and as far as getting the cell phone out, you just go like this, quite tight, but it'll, there. So now all I have to do is put some Velcro. I don't know if I'm going to fold it over or put it together. I think I'll put the Velcro so it comes together like this.